Hi guys. Good. Oh my god, focus. So hi guys, how are you doing? Today I will show you some nice demonstration. We're going to demonstration the Einstein formula. E is equal mc squared. But to take this formula, first we make a deduction. And I hope you like it. Well, first of all, we need just two equations, the equation of momentum linear and the factor Lorentz. Well, I forgot the factor Lorentz. Okay. We transform this normal movement in a relativistic movement on a particle m0, which means m0 is the particle on a relativistic movement. So I will just make a substitution aqui. And momentum linear is m0 plus v plus 1 over, oh I forgot this, 1 over 1 minus v squared under c squared elevated by 1/2. Okay. Let's write here. So my v is equal to m0 1 minus v squared c squared elevated by 1/2. Oh, I forgot. Well, if you see some white smoke around my table, it's because I'm using my humidifier because I had a sinusite attacks. I had a sinusitis attacks minutes ago, so it's not drug, I swear. And okay, let's move on. I want to make a derivation under v in this way, all these function over dv. Okay, so what is my next step? I will put this, no, I not put nothing, forget. So my gp dv is equal what? My pdv is equal to a product rule when v is my first function and this strange function is my second function. Okay, but first I will arrange this that way under dv. The mass is a constant, so he can take the left side. V is equal times 1 minus v squared c squared 1/2 here. Next step, I will put this on the upside. My dv it's equal to dv m0 v 1 minus v squared c squared minus 1/2 because it's the inverse function, so in an inverse function, the power turns in a minus sign. So let's make the product rule. I hope you know what means this. So the product rule statement, the first, if we have two functions, and I have a product of this function, if I will make a derivative of the first function plus the second function plus the first function multiplied with a multiplication with the second function plus my first function times the second function with derivative. Okay, so let's make this in here. My dv is equal m0 because it's a constant dv. So let's make the power rule. dv over dv plus the second function, which this is this 1 minus v squared over c squared 2 minus 1/2 plus the first function v times the second function. But I want you pay very attention here because we do not make one simple derivation of this function because I have two functions here. The function inside this parenthesis and the all function. Okay, so we have to use the chain rule. The chain rule, which statement if we have a g function inside of the f function with a derivative, we have to make the derivative of the whole function times the inside function. Okay, so let's do it. This function I will make the product rule or the power rule, which means my exponent will goes to down, and I will make a simple, I don't know how to say that, a simple just put minus 1 here plus the inside function inside this parenthesis. What is the derivative of a constant? Right, is 0. What is the derivative of this part of the function? Well, my c squared is a constant, so I don't do nothing. Turns out we have this equation. Okay, now we'll, after making this derivative, I don't know, I say derivative, it's derivative, but I think you understand very well. So the next step is to make our dv equal to my mass. dv over dv is 1. 1 minus v square on the c square minus 1/2 plus I will just repeat what I have done here, times this part of function is minus 3/2 plus this 2vc squared. So not something interesting. We have minus signer here and we have the minus signer here. This with this turns out into a plus sign. So, and the next interesting, we have minus 1/2 here with 2 plus other thing here. 2 with half is 1. It's equal 1. dp under dv could be equal to my mass v square c square, you know that, minus 1/2 plus 1 times this is this 1 minus v square under c square minus 3/2 plus I have the v in the right side and the c square on the downside. So my v is equal to c square. Okay, and I will put this function on evidence right now. My m0 will be equal, will be times my v square and the c square minus 1/2 times all this shit. Here I will have 1 plus v on the c square times 1 minus v square on the c square minus 1. Okay, next step, my dp over dv is equal to m0 1 minus v square and the c square. One minus, and now if I had minus the power minus 1, I could make only this. If I had c square down, I can multiply c square in both sides and turn this on, be it's equal to c square plus c square under c square minus v square. This c square will cancel with this c square, so my dp under dv is equal to my m0, my mass 1 minus v square under c square minus 1/2 1 plus v under c square minus v square. Okay, everybody, I hope everybody is understanding what I'm saying. Each step you will need to take a sheet and a pencil and writing just like me until you couldn't you can understand every single step, because it's the most important step of it. For to you learn everything is make this process, okay? So my next step, I will just make this tank, I guess. Oh, no, I don't make this tank. I hope, no, I can write this. TP under GV is equal to, now I have the, what is I supposed to do next? Oh my god, guys. I suppose nothing. I'm kidding. So, oh, I got it. 9/2 is, we just make it this. Or if you don't know this step, you could take this c squared minus c squared and multiply c squared minus b squared here and divide it by c squared minus 5 squared here, because this divided by this is equal to 1, which is the same thing. C squared minus v squared under c squared minus v squared plus the same denominator and my v on the top. Okay guys, I hope you understand this. Each step you understand very well. So let's move on. Oh, I forgot. I had this v, and I can multiply with this v. So turns out this v here, the first v, multiplied by this, we have a v squared here, v squared here, v squared here, v squared here, and v squared here. This is important. So I make this mistake here. So, okay. Next sheet. We just repeat P over the V. I think it's boring this video because I am talking too loud and I don't know, but I think this is a interesting video because I'm making deduction of the Einstein formula, so I hope you enjoy, guys. What I done until now. Okay. Next step, m0 plus 1 minus v squared under c squared over this times c squared minus v squared plus v squared under c squared minus plus this is this. So next step, my dp over dv is equal to m0 this and this. Minus v plus minus v squared plus v squared cancel both. C squared under this is a square, guys. C elevated by 2. Okay. P under the V and 0 b squared c squared minus 1/2. So I will make a complex but not so much step. This is equal to, oops, it's minus here. C squared minus v squared is equal to this little baby, okay, which is this little baby right here, okay. Try demonstrate this, and you can just do it. So we will, if this is this, we have a product of the both power, and 1 minus v squared under c squared is equal elevated by 3/2. Okay, so that is the formula that I'm looking for until now. And now we will use the integral formula. This specifically integral, it's not a vector, so I will make this rearrange. My force is dv under dt times dx, but this is my dv under dt. Until we forgot this, we have a mass, so mass times v is what? It's my momentum linear. Just like in the first equation, momentum linear. Or linear moment, I don't know. And I just want to go to sleep, but I'm doing this for you guys. And TV, okay, TV. 0 to v. But if I could make write this, I have to change my limits, so we will make the I don't think it is. I guess I will make this right now. Turns out this will be minus 1v c squared, and this is 1. Again, you can demonstrate this, but guys, we have almost 25 minutes video. I don't have any time to do it. Before we accelerated this, I'm sorry, but I can't really more this video. So my work is the same thing of the change of the energy. So work is energy, okay? It's a theorem. So this is my work. I forgot to say that. This is my formula to work. So let's apply. I will apply this formula. My work is the integral 1 minus v squared under c squared. I will call a is equal to 1 minus v squared over c squared. Derivating, you will get this minus 2v over c squared dv, and my dv is equal to minus c squared over 2 times dA. That is the formula that I want. So I will have this times dA, which is my work is equal to, again, my m0, and this part is a constant, so I will take in the outside minus c squared over 2 plus 1 minus v squared under c squared. This thing dA, m0 c squared over c. I just make the rule of the integral, the basic rule of the power integral. So I hope that's not a surprise for you. Plus 1 here, and I get the limits here. My work is m0 times c squared under 2 minus 2 plus minus 1/2, and my limit is 1 here, 1 minus v squared under c squared here. Oops, sorry guys. My work here is my m0 times c squared, 8 elevated by 1/2, and my limits again. Okay. Turns out that I have this constant, so I will ignore it for now, and I have to put this limit on here. One minus v squared under c squared elevated by minus 1/2 minus 1 elevated by minus 1/2. Okay. And my work, which is also energy, will be exactly here. Oops, minus v squared under c squared elevated by 1/2 minus m0 c squared 1 elevated by minus 1/2, which is 1 plus. Okay. My work which is the difference of energy, will be m0 c squared minus 1 over the factor Lorentz right here minus m0 times c squared. That is the real formula. The real Einstein formula. But what this means? E equal mc squared is wrong? No. But this formula is applied just when my energy, I have a stationary energy, okay, which means a potential energy I have a potential energy, so it's okay, potential energy, but my kinetic energy is 0, so I don't have kinetic energy when I have a stationary energy, a particle in a stationary energy. It don't move on, it don't have a great result. So that's it. Oh, I think that's it. I'm really tired now. I guess I changed this, so I will put some days on comments. So if you like it, leave comments below. If you don't like, I don't know what to say, so I will sleep now. I hope you enjoy, and that's it. Bye bye, until next video.